Page 4. Page 4 is going to show you a blank graph, and it's going to ask you to graph a few different substances. Even though they give me a lot of densities here, I'm only interested in this one, tin, iron, and silver. I'm only going to be interested in this number, and this number. I have to graph lines like I saw on the other page and draw a nice straight line, and it'll go through the origin 0, 0, because of course 0 milliliters of anything, 0 grams. But the tough part would be, what does this really mean? It means 7.31 grams for every 1 milliliter. It would be tough for me to come over here and find where 7 would be versus 1 and to get a nice straight line. So I don't have to pick the 0.7 meets 1. I could pick any multiple that still has the same ratio. It could be 14.62 meets 2. It could be 21.93 meets 3. What I'm going to do is just pick the easy one and do it. If I times this by 10, it'll equal 73.1 grams per 10 milliliters. So if I go up to 50, 60, 60, 70, 73 would be around in this area. I need to know where it meets 10 milliliters. I don't need that line, just showing it so on the video. So 73 meets 1, and then I take a straight line and go from 0, 0 to there, or a relatively straight line. That is tin. Iron, very similar. Its density 7.87 grams per milliliter. I'm going to use my same multiply by 10 trick, and instead of 7.87 grams per 1 milliliter, 78.7 grams per 10 milliliters. I find where 70, 80, 78.7 meets 10, and I'm going to have two lines that almost touch each other. Does that make sense? Well, yeah, look at their densities. Their densities are very close to one another. So iron would go there. Finally, silver. Silver is 10.5 grams per every 1 milliliter. I could probably even graph that. Here's 10, and here's 1. And so I would probably put a line that kind of went like, and let me just do this freehand. Now, I'm not sure if that's really right. It sort of hits out in no man's, and I'm not really sure. So maybe I'll go back and do my trick. 10.5 times 10 is 105 grams for every 10 milliliters. So let me go up and make a point up here where it says 100, that would be 110, 105 meets 10 milliliters. So I'm finding doing it with just the density probably didn't work out very well. If I project a point out there, I'm going to get a much more accurate look of where it should be. Silver. I won't triple check them on the test, but using that trick to get a point further away from the origin is going to make you do a little better. What if you made some cubes out of some metal? That is 3.5 centimeters by 3.5 centimeters by 3.5 centimeters. What would its volume be? 3.5, not times 3, but cubed. So 3.5 times 3.5 times 3.5 equals 42.9, if I round, 42.9. The logic I used for rounding to 42.9, if I went to 1/10 past, I'm going to go to 1/10 past. I don't want it to have extra digits over that. Realistically, if I use sig figs, I would probably just say 43, but we don't right now need to discuss sig figs. So 42.9 centimeters cubed. This question is just asking you, do you remember that cubic centimeters and milliliters are exactly the same thing? Just the way they designed the metric system? So that's also 42.9. So every one of these is 42.9, and they're going to say you got 3 cubes. Find the mass of these cubes. One's made of titanium, one's made of gold, one's made of iron. The work's going to look very similar. Every time we're going to start with 42.9 milliliters. Every time we're going to multiply by a fraction that lets us cross out milliliters, because what we really want is mass, which is grams. So the only difference between these is, where do we get the numbers or information? What's the relationship for grams per milliliters? We go back up to these substances. All the substances asked about are there. For instance, titanium is 4.54 grams per milliliter. So 1 milliliter is 4.54 grams. I would multiply that. Gold is 19.30 grams per 1 milliliter. So I would write 19.30 grams per 1 milliliter. And iron is 7.87 grams per milliliter. So I would write 7.87 grams per 1 milliliter. Then it's just crunching the numbers. 42.9 times 4.54. I'm going to double check, is that a 4 or a 9? It's a 4. 194.8. 194.8 grams. 42.9 times 19.3. 828.0 grams. Once again, I'm not following significant figures as much as I am using the logic of I'm going to round to the same place past the decimal as they measured. Significant figures, I probably would have put 828. Finally, 42.9 times 7.87 equals 337.6 grams.